Hi, welcome again. Today I'm going to show you interactive geometry animation. So here we can see a sphere over there, and let me walk to that. So you can see as I move closer, it changes the geometry as well as how it animates. See? Like this. And then let me turn on the wireframe mode. You can see how it works. Here we run all the calculation on the GPU to get this position, and we have a CPU version as well. Basically they are identical in terms of how they look, but how do we calculate the position is totally different. Blue one is on the CPU and the green one on the GPU. Alright, let's get started. First, I really encourage you to get OpenLand Mesh from the marketplace or from GitHub. Just check the description on this video, and then go to the getting started guide and learn up to animation. Then you are comfortable following through this tutorial. From your content browser, make sure you enable show plugin content and then search for OpenLand Mesh from the content directory. And here we have example directory, and then we have blueprints directory. We have some example. Here these are the two examples that I just showed you: interactive sphere, CPU and GPU. Now we have focus on the interactive sphere CPU one. Let me double click on that and open the blueprint. First, go to the component and select the root component and go to the details panel of the OpenLand Mesh section. You can see we enable subdivision level to 5. We have smooth normals, and we allow to animate, and then we allow to run CPU Vertex modifier. Let me go to the my blueprints section. Here we have two functions: get polygon mesh, which get the cube mesh as a base mesh, and then we have on modify vertex. We do all the geometry calculation here. It looks a little bit complicated. Don't worry, I'll explain everything. The first thing is we get the position, and we normalize that, and we get the unit vector, and then we multiply that with this radius. Then we get the sphere like this. And we have another vector. Usually that vector is something on top of this sphere, and I'll explain why we need this in a moment. And then we get the distance from each and every position on the sphere. Okay, then we multiply with the frequency, some smaller value, and we move that into the sine function. And also we enable the animations using adding the time as well. And the sine function is always returning -1 to 1 range, so we multiply that with some big number with some amplitude. We get that one, and we multiply that with the vertex normals, and then we add that to the position, and we will get some wave kind of look. And we have something interesting over here. Just don't worry about that. So let me connect this wire to my position, and let me compile it. So you will see something like this. About the distance root, let me change this position. It's right now on the top, and let me put somewhere on my y-axis, and I'm gonna hit compile. So you can see it changed the direction to some place like this. So we're gonna use this distance root as the player's position, so we can interact our geometry with the player. Alright, let me reset this, and then let me simulate this, and yep, that's how it looks like. Alright, now why you have something like this select vector, something interesting. So here we have two steps in OpenLand Mesh. One is the building stage, so we create the geometry initially, and then we modify it many times. That's how we do animation. So here we provide two versions when we are building the geometry, and also we are animating. So that's what this select vector does. And here we have pick A. So we pick A is this boolean coming from payload on building. So here, so we will change this variable based on whether it's building or not, and by doing that we can pick different values. If this is building stage, we will use the sphere. If not, we're gonna use this interesting animation, and it will help the animation to work smoothly. And then let me put this, and let me run the app, and you can see it's working as expected. So then you wonder how actually this interact with the user. So let me show you how to do that. So let me go to my event graph. Here we have some logic created on an event called on after animation. So let me delete this and start from the scratch. All right, I'm gonna compile. And here on the functions, we have override button, and now we have another function to override called on after animation. It's coming from OpenLand Mesh active, and I'm gonna hit that. So that's how you get this event. So this is very similar to the tick event, but this is different. This runs after the animations are completed. So in OpenLand Mesh, we run animation as a background job. Then if you update variables inside the tick, that will affect the animation. So that's why you need to use this one. Then let me connect this into this logic, and this is how it works. So here we get the player's current location, player characters, and we get the current location of this actor, this sphere, and these values are on the world positions, and then we subtract each and other, so then we get the local position. So because every calculation here we do based on the local position, so this animation only works with the 10 meter radius from the root of this object. With this we get 0 when the user in the middle, and we get 1 when the user is a 10 meter radius, and then we subtract by 1 so we get the 1 at the root and 0 at the end of the 10 meters. So that's useful to do a couple of interesting things. So we multiply that value by 10, we get that as amplitude, and we multiply that by 0.2, that's the frequency. So basically if you move away from this sphere, we reduce the both amplitude and the frequency. And then we get the local position that I showed you earlier, and we multiply that by some small values, and we add this to this vector. So basically we are not setting that exact position as the this distance root that I mentioned earlier, but we get a little portion of that and put it in this top vector, okay, and then we set that as a distance root. And if you don't understand this, just play with these values and you'll see what I'm talking about here. So I'm gonna compile and save. And basically that's it. So that's how you got this animation. Alright, now I mentioned we have another one for the GPU, and let me double click and open that, and it's completely the same idea. And on the OpenLand Mesh section on the details panel, we are running a GPU Vertex modifier, and we have a material over there. So we go to that material. So basically we get the position, sphere, maybe we are making a sphere. Now we have all the frequency, distance root, and all the same logic created in this material. And then we have with building function, which we can provide one version when the mesh is building for the first time, and there's another version when the mesh is modifying. And we put it as output, and that's it. So it's simple as that, and we have some parameters for the amplitude, frequency, and you name it. Okay. Then how do you interact, how do you update these values? And quite simple, and go to my blueprint selection, and we have the same event on after animation, and we do the same calculation, get the play character, and the same calculation I mentioned earlier. When we are updating these parameters, now we have something different. We have a new function called set GPU scalar parameter, and like this, and we have GPU vector parameter for updating the sum vector. And that's how we created this very interesting interactive animation. All right, see you soon with a different tutorial. Bye.